Yes, Krishna. Okay, so almost 2:31. So write down the first question. Write down the first question. We'll start with very basic question. Write down which one of the following is the unit of electric charge? Which one of the following is the unit of the electric charge? So options are given, but you know that basic unit of charge is nothing but coulomb. I'll read out the options and you can write direct answers. Coulomb, volt, Newton and coulomb per volt. So answer is what here? Coulomb. Okay. I'll repeat the question. Which one of the following is the unit of electric charge? First is option is given coulomb, second volt, B Newton and D coulomb per volt. So answer is coulomb here. Okay. Write down next question. This is very IMP. Write down relative permittivity of a water. Relative permittivity of a water is 81. Relative permittivity of a water is 81 if epsilon W and epsilon naught are the permittivities of water and vacuum, permittivities of water and vacuum respectively. Then options are given. Write down the options. Options are given here. Epsilon naught, first option is given, epsilon naught equal to 9 times of epsilon W. Then epsilon naught is equal to 81 times of epsilon W. Epsilon W is equal to 9 times of epsilon naught. Then last option, that is epsilon W is equal to 81 times of epsilon naught. Okay, so here relative permittivity of the water. Relative permittivity means according to our theory we have relative permittivity, we are denoting by letter epsilon R or we are denoting by letter K. And here relative permittivity of a water is given, that is 81. Okay, and here epsilon naught is the permittivity of a water and epsilon naught is a permittivity of a vacuum or air. Okay, and here we know that K is nothing but epsilon W by epsilon naught, because we did this derivation. K is equal to epsilon M by epsilon naught. Epsilon M is a here medium and here epsilon naught is a permittivity of the air or free space or vacuum. Here this is medium and here medium is nothing but what? Water. So I can write K is nothing but given 81 epsilon W by epsilon naught. Therefore epsilon W is equal to 81 times of epsilon naught. So correct answer is option D. Getting how to solve very basic question. Okay, if you know the formulas, then only you can able to solve the answers. Getting this? Is anyone having doubt in this question? Okay, everyone copied? Chalo, write down next question. The force of repulsion between two electrons Write down the question. Force of repulsion between two electrons at a certain distance is F, capital F, full stop. The force between two protons separated by the same distance is, and in bracket one information is given, that also you can write down. That information is there, that is mass of a proton is equal to 1836 as that of mass of a electron, and options are given 2F, VF, C 1836 F, and D F upon 1836. Okay, so these are the options, and here question is that the force of repulsion between the two electrons, okay, is nothing but F, and the force between two protons are separated by the same distance is, and the options are given. Okay, so this is very easy question. Okay, to make you confused, they gave this information: mass of a proton is 1836 times of mass of an electron. If you draw the diagram, okay, suppose here we have two electrons, okay, E and E, they are separated by distance r. Okay, here two electrons are there and they are separated by distance r, and they are giving the force in between is nothing but F. That means Q, K into Q1, Q2. That means E1 into E2 E square divided by R square. This is what the force in between these two electrons. Now in another case, what they are saying, they are replacing these electrons by proton, but the distance will remain same. Again proton, both protons are keeping, then again in proton also same repulsion is there, no? Okay, here no mass, we are not considering mass. So suppose if we are keeping proton over here, then force F is equal to what? K Q into Q1 into Q2 by R square. Distance will remain same, they are only same, the distance will remain same. There is also force of repulsion because both are protons, so force will remain constant, that will not be a change. So option B is the correct option. Just by giving this mass relation between proton and electron, students are not get confused. So whether the answer will either this or this 2F, no. The force will remain same. Even in normal classes we did the same question. I asked you to find out the charge and what is the force in between them. So force is given, the same force is acting on both the charges. Okay, so answer is nothing but here F only. Because here separation is same, then there is a force of repulsion between both the proton, that will also remain same. Getting these questions, how to solve MCQ? Can you getting? Now write down next question. Next question very IMP, mark it as a 5 star. Two-point charges of plus 3 microcoulomb, 2-point charges of plus 3 microcoulomb and plus 4 microcoulomb respectively respectively repel each other with force of 10 Newton. With a force of 10 Newton, full stop. If each is given an additional charge, of -6 microcoulomb, comma, the new force is first option 6 Newton, second 6.5, third is 5 Newton, and last is 7 Newton. I'll repeat this question. 2-point charges of +3 microcoulomb and +4 microcoulomb are repelled each other with a force of 10 Newton. If each is given an additional charge of -6 microcoulomb, the new force is 6 Newton, 6.5 Newton, 5 Newton and 7 Newton. देखो? So normally how we are thinking, okay, two charges are there, +3 and +4 microcoulomb, they are repelling with each other and the force between them is nothing but how much? 10 is given. 10 Newton is the force given. Okay, but the thing is that up to here it is okay. But after that they gave one statement, that is if each is given an additional charge of -6 microcoulomb. Okay, then they are asking what is the new force. Okay, so here what I will do, we have charge Q1. No? Initially we have charge Q1, that is how much? We have +3 microcoulomb. And Q2 we have +4 microcoulomb, and the force in between them is nothing but 10 Newton. Okay, this is what the given condition. After that they are saying what? Here they are adding -6 microcoulomb charge. Okay, here they are adding -6 microcoulomb charge into the original charge. So if we add -6 microcoulomb into the original charge, then what is my new force? Okay, whenever there is a 3 microcoulomb and 4 microcoulomb charges are there, in that case force is 10 Newton. But here what they are saying, if you add -6 microcoulomb charge in each charge, means what here? Q1 is nothing but 3 microcoulomb -6 microcoulomb. Adding means here this 6 is nothing but what? -6 microcoulomb. So this is 3 minus 6 is nothing but -3 microcoulomb. And Q2 I have how much? Plus 4 microcoulomb plus minus here 6 microcoulomb. So here I will get -2 microcoulomb charge. But for Q1 -3 microcoulomb and for Q2 -2 microcoulomb, what is my new force? New force I will take it as a F dash. What is the new force? That I have to calculate here. Okay, so what is the force? Force, so I know that according to Coulomb's law, force is nothing but K Q1 Q2 by R square. Getting this? So how can we solve this? Therefore, here if I draw this diagram, initially +3 microcoulomb and then 4 microcoulomb, they are separated by certain distance r. Okay, now here I added the charges so that these charges are become as -3 microcoulomb and -2 microcoulomb. They are also separated by distance r only. So suppose here F dash, if I am writing K, Q dash, Q1 dash or Q2 dash divided by r square. Okay, and suppose this is my equation number 1 and this is my equation number 2. So can I take a ratio F by F dash? That is nothing but F is nothing but K Q1 Q2 upon r square. and here f dash is nothing but k q1 dash q2 dash 2 divided by r square. If you take a reciprocal, then k q1 q2 upon r square into r square upon k q1 dash and q2 dash. R square get cancelled. K and k is also get cancelled. Now q1 q2 are nothing but 3 into 4 into 10 raised to minus 12 because microcoulomb. Okay, minus 6 become plus minus 12, and q1 and q2 is we are taking magnitude 3 into 2 into 10 raised to minus 12. Minus 12 get cancelled. 3 and 3 get cancelled, and this is nothing but how much? 2. So here f upon f dash is equal to 2. But this is not my answer. They are asking f dash. So you can transpose to this two side. So here I can write f divided by 2 is nothing but your f dash. But this f dash by 2 is not an option, no. But here I know f is nothing but how much here? 10 Newton. So I will substitute here 10 by 2 is nothing but 5. So here f dash you will get it as a 5 Newton. Can you getting this answer? Actually this is 3-mark question, but they are asking MCQ. That's what this question is very important. So they apply the Coulomb's law but in a different way. Okay, whenever they are saying addition of charges, then take subtraction is there or difference is there, you can subtract it. Getting this? Use the logic, try to understand the concept. Okay, they will ask straightforward numericals. There is what somewhat twists and turns are there. Try to understand this. Getting this question? Check it properly and copy. Can you all getting? Can you getting? Understood this? Write down. So questions may not be straightforward. They are asking like this only. This is just I covered one type or variety of a question. Okay, everyone copied? Okay, everyone copied? Chalo. Write down the next question. Okay. Write down. Write down 3 equal charges. Three equal charges are placed. 3 equal charges are placed on the 3 corners of the square. On the 3 corners of the square. Full stop. if the force between Q1 and Q2, the force between Q1 and Q2 is F12, and that between Q1 and Q3 is 1/3. Q1 and Q3 is F13. Q1 and Q3 is F13. The ratio of magnitudes F12 by F13 is, the ratio of the magnitudes of F12 by F13 is. Okay. So here the question is what? 3 equal charges are kept on the 3 corners of the square. अभी स्क्वायर को तो 4 corners होते हैं, that means they utilize only 3 corners and they kept equal charges on the 3 corners. Okay. So first I'll try to draw the diagram here. So you can check here. This is a square. Okay, I'll name it as A, B, C and D. They kept equal charges. Take it as a Q, Q and Q. Can you getting this? Okay. So these are nothing but what? The charges they kept. Okay. So if you want, you can just take it as a 1, Q1, Q2 and Q3. Okay. And here which forces? F12 and which one is there? F13. Okay. They are interested in F12 and F13. So here F12, that means this Q is acting on Q1. Okay. So I will use another marker to show this. So this is Q2 and Q1. So this Q2 is acting on a 1 and this Q3 is also acting on 1. How I can come to know that? Because here F12 and F13. Okay, means Q2 is acting on 1 and Q3 is also acting on Q1. So this distance, this is a square, so each side is what here? Same. But Q3 is acting on Q1 on a diagonal. Okay, so this distance is, we have to find out. So we know that diagonal of a square. We did same problem, but we consider all the 4 corners, that is root 2 into a. That means I come to know that this is root 2a. Because here if we are applying Coulomb's law, then in Coulomb's law we must know what is the sign. Okay. So F12, so you will get it. What is F12? F12 is nothing but K, Q1, Q2 upon, we can say that a square. Okay. And F13 is nothing but what? Q3 is acting on Q1. So K, Q1, Q3 divided by root 2 into a whole bracket square. Can you get it? I just applied here Coulomb's law, nothing else. Can you getting this? Okay. And here very important thing, just for understanding purpose, I took these charges as a Q1, Q2 and Q3. But they are saying all the 3 charges are identical in nature. So they are asking the ratio of what? F12, no? Yeah. So here ratio F12 by F13. So F12 is nothing but what? K, Q1, Q2 upon a square divided by, here we have K, Q1, Q2 by root 2a square is nothing but how much? 2a square. So here Q1, Q3. Okay. But here in statement they are saying charges are identical. That means Q1 and Q2 is nothing but same Q1 only, that is Q square. Q1 and Q3 are also same, that is Q square. So I will write here K, Q1, Q2 by a square into twice of a square. This is get reciprocal K, Q1, Q3. K get cancelled, A square get cancelled. Q1, Q2 are nothing but here Q1, Q2 and Q3 are identical and we are taking it as a cube. So these charges are also get cancelled and you will get the ratio F12 upon F13 is nothing but 2 by 1, or you can write only 2 also. Can you getting this question? How I solve this question? Can you getting? We did half, but in normal class we did full for 4 sides. Here only they ask the same question but only using 3 corners. So okay, this kind of changes they are making. Everyone copied? Is everyone copied the answer from the board? Can I go for the next question? Okay, I will take a screenshot. Afterwards, I will send it to you. You are not able to see? I will send it to you afterwards. I took a screenshot. Okay. Okay, it's okay. No issues. Wait, I will just make it focus. Now can you able to see in the work? I will send you afterwards. Okay. So write down next question. Write down, which of the following is deflected by electric field? Which of the following is deflected by electric field? First option, X-rays, B, gamma rays, C, neutrons, D, alpha particles. D, alpha particles. I'll repeat this question. Which of the following is deflected by electric field? First, X-rays, gamma rays, neutrons and alpha particles. So you can write down the answer here. Alpha particles only deflected. Okay, that we can discuss it later, but here alpha particles are deflected by the electric field. Okay. Okay, write down next one. If the charge on the object is halved, that is half, then electric field becomes first half, second double, C unchanged, and last is thrice. And repeat this. if the charge on an object is halved, then electric field becomes half, double, unchanged and thrice. Okay. So electric field intensity they are asking if the charge is get halved. So those who know the theory and those who know the relation between electric field and charge, they can easily choose the option. Okay. We have electric field intensity is nothing but kq by r square. Okay, and electric field intensity is directly proportional to q. So here q is gets halved, then electric field is also what? Gets halved only. Okay, so option is half. So if you know the theory, if you know the relations, then it's very easy to choose the answer. Okay, so option is half. Okay, copy. Then write down next question. A force of 2.56 Newton, a force of 2.56 Newton acts on a charge of 16 into 10 raised to minus 4 coulomb. 16 into 10 raised to minus 4 coulomb. 4 coulomb. The intensity of the electric field. The intensity of the electric field at that point is first option 1600 Newton per coulomb, B 150 Newton per coulomb, C 16 Newton per coulomb and D 1.5 Newton per coulomb. Okay, so here the force of I will repeat this. A force of 2.56 Newton acts on the charge of 16 into 10 raised to minus 4 coulomb. The intensity of electric field at that point is first option 1600 Newton per coulomb, B is 150 Newton per coulomb, C is 16 Newton per coulomb and D is 1.5 Newton per coulomb. Okay, so here this is also very clear and straightforward question. So here force is mentioned and we have to calculate electric field. So first you can write down the given things. Force is given 2.56 Newton, correct no? And then charge Q is given 16. Charge Q is given 16 into 10 raised to minus 4 coulomb. Then we know that electric field intensity is nothing but F by Q. So F is 2.56 and Q is 16 into 10 raised to minus 4. Simplify this. Okay, simplify this. Check how much you will get the answer. Check which option is the correct option. Utilize that two zeros also. Is it 16 and these two zeros? Newton per coulomb. E. Yeah, your electric field intensity is 1600 Newton per coulomb. I think here, yeah, A is the correct option. Okay, getting these questions? Is everyone getting how I am solving the questions? If you know the theory, then it is very easy to understand. Okay, finished. Write down next question. Write down next one. A conducting sphere of radius 10 centimeter. A conducting sphere of radius 10 centimeter conducting sphere of 10 centimeter, radius 10 centimeter, has unknown charge, full stop. If the electric field at a distance of 20 centimeter from the center of sphere is 1.2 into 10 raised to 3 Newton per coulomb, and points radially inward, full stop. The net charge on the sphere is, I'll repeat this part first. A conducting sphere of radius 10 centimeter has unknown charge if the electric field at a distance 20 centimeter from the center of the sphere is 1.2 into 10 raised to 3 Newton per coulomb and points radially inward. The net charge on the sphere is, write down the first option, minus 4.5 into 10 raised to minus 9 coulomb. First option 4.5 into 10 raised to minus 9 coulomb. Second option 4.5 into 10 raised to plus 9 coulomb. 4.5 into 10 raised to plus 9 coulomb. C third option, minus 5.3 into 10 raised to minus 9 coulomb, and last option 5.3 into 10 raised to 9 coulomb. 5.3 into 10 raised to 9 coulomb. Okay. Now here conducting sphere, radius is given, r is equal to 10 centimeter. Convert that into meter. Okay, and it has an unknown charge, and that unknown charge only we have to calculate. And this they are asking here the electric field at 20 centimeter. Okay, that means axial line ka derivation we have to take. And here the center of the sphere means electric field intensity is also given. Okay, easy. So we have to calculate here unknown charge Q. Okay, so here very important thing, first write down all the quantities. R is nothing but I think 10 centimeter, correct? R is, sorry, not 10, it's 20. So 20 centimeter means 20 into 10 raised to minus 2 meter. Okay, and electric field intensity E is given 1.2 into 10 raised to 3 Newton per coulomb. Now the thing is that they use one word. The electric field intensity is radially inward. Okay, radially inward means of course that charge should be what? Negative. Okay, so that charge should be what? Negative. So that's what I will give here, sign negative. Okay, and we are interested in finding out the unknown charge Q. So how to calculate this charge Q? Okay, so we have the formula KQ by R square, that is electric field intensity at the axial line, that is nothing but KQ by R square. We are interested in Q, so keep Q as it is, E into R square divided by K. So E is nothing but minus 1.2 into 10 raised to 3. R is nothing but 20 into 10 raised to minus 2 whole bracket square divided by 9 into 10 raised to 9. Okay. Now simplify this. Nine, and here I will write it as minus 9. Okay. Simplify this. Yeah, it's simple calculation. 12 fours are 60, and that is divided by 90. So divided by 9, that is nothing but minus I think 5.3 into 10 raised to minus 4 minus 13, that is 10. And here you can adjust the decimal, so that once you adjust the decimal you will get minus 9 coulomb. Okay, so this is what the charge I am getting. Check here, 12 by 90 into 400, so 12 × 60, 60, and these two zeros, 90, 0, 0 get cancelled, 3, here 2, 0, 0, then if you divide here by 3, yeah. Oh, it's 48. Here I am getting 48. Yeah, it's 5 minus 5.3 into 10 raised to minus 9 coulomb. Yes, option here correct. C is the correct option. Yeah. Okay, copy this. Some simple calculations are there. but you should remember here they didn't mention the sign, but 100% they can they are using this word radially inward or outward. Outward is there, then no doubt it will come positive with negative power, and it is inward, that means it will come with negative sign. Copy this question. Okay, if you know the theory for this chapter, if you are reading NCERT line to line, then it will be very easy to find out the answers for the given MCQ. Some MCQs are straightforward, some are not straightforward, so you have to use the logic which you learn or the concepts which you learn in this chapter. Okay, so here they are saying radially inward, that means here negative charge is there, so answer will come negative. Otherwise we are solving with a positive sign only. Okay, so you should be alert while solving and reading the numericals. Okay, now next one write down. Next question is also very important. Write down. A metallic sphere is placed in a uniform electric field. If a metallic sphere is placed in a uniform electric field, full stop, the line of force follows the paths shown in figure. This is also a very important question. Last year in many schools they asked this question. This is actually came for JEE very long back, but this question becomes popular afterwards. Okay, a metallic sphere is placed in a uniform electric field. The line of force follows the paths shown in the figure as. So I will draw the figure. Those who are studying, self-studying, they know this question. This is very popular question. So make it single star. Okay, and draw this figure. This is a sphere given, metallic sphere, and here this is the first path. Okay, this is first path. Second path, it comes here and it enters and again it comes out. This is the second path. Then third path is same as that of first one. This is third. And fourth is, it's going like this and it's coming out. Okay, this is the fourth path. Okay, so here we have to find out the here what they are asking, the line of force follows the path, different paths. So here a metallic sphere is placed in a uniform electric field. Okay, so if this sphere is kept in a uniform electric field, we did this during the class also. The charges are what gets evenly distributed on the surface. Okay, so inside the sphere there is no charge, no electric field lines will move from this sphere. So in first figure it is going out, means it is going through this sphere, which is not possible. Second also they try to find out here tangent, that is also not possible. 3 is same as that of 1, but here in fourth case they are going to this plate and they are what? Reverted, and they are going to the second part. They are not traveling inside the sphere, because electric field intensity inside the sphere will become how much? 0. Okay, so all the three parts, first three parts are wrong, only fourth part is here correct one. Okay, so write down here option here, yeah, fourth part. Okay, because field inside the sphere is nothing but what? 0. Copy this. Now write down next question. Which of the following figure represents the electric field? Which of the following figure represents the electric field lines? Which of the following figure represents the electric field lines due to a single positive charge? Due to single positive charge, and here different figures are given over here. I know those who knows the theory, they can immediately tick the answer. So first bit they given as here, first bit they gave it as, so this is positive radially outward. So second figure, this is positive. These are the field lines going towards the charge. Last option they kept here positive charge and electric field lines are passing like this. The last option is given, electric field is going in this direction, positive charge is kept it like this. So these are the option. Okay, so now tell me which one is the correct option here. They are asking which of the following figure represents the electric field lines due to a single positive charge. Which option will come correct? You can just type the answer. I will not solve this question. Can someone type which one is the correct option over here for a single positive charge? We discussed during the classes. Okay, if charge is positive, if charge is negative, equal and opposite charge are there, then how is the electric field line representation? That I already discussed. Tell me. Yes. Yes, correct. Yeah, option A is the correct option. I think all are sleeping. It's sleeping time, I think, correct? Write down next question. We all are sleeping, means you people are sleeping, correct? Yes or no? Choose the option and write. According to ma'am, all the students are sleeping. Option A, yes. Option B, no. Who Rujul gave the answer means Rujul is waking up and all other students are sleeping. How many are joined? Just message. Array. What? Who all are there on the link now? Or simply you kept on and all are sleeping? Who all are there? Can type a message, yes, I am here. Okay, leave it. I'm wasting time. Write down next question. the electric field near a conducting surface. Okay, Mayuka is there, Prakrut is there, Rujul answer means Rujul is there. Then all other I don't know. All other are sleeping. See, Prakrut is so energetic. Just now he reached eating khakra and is typing answers. Good Prakrut, very good. Write down the question. The electric field near a conducting surface. The electric field near a conducting surface having uniform charge density is given by first option sigma by epsilon naught and is parallel to the surface. Option B, 2 sigma upon epsilon naught and is parallel to the surface. Option C, sigma upon epsilon naught and is normal to the surface and last option, 2 sigma upon epsilon naught and is normal to the surface. Okay, I'll repeat these options along with the question. So the electric field near a conducting surface having uniform surface charge density is given by sigma by epsilon naught is parallel to the surface, 2 sigma by epsilon naught and is parallel to the surface, sigma by epsilon naught and is normal to the surface, and last option, 2 sigma by epsilon naught and is normal to the surface. Okay, so here electric field near the conducting surface and then surface charge density, we know that. Okay, surface charge density, having surface charge density is given by electric field we already calculated, no, sigma by epsilon naught. This derivation we derived actually for the plate, okay, where the charges are what, equally distributed on this plate. Okay, this derivation we did. So here how the electric field lines are there, normal to this plane. So option is check now, E is sigma by epsilon naught and the lines are what, normal. Electric field are what, normal, no, they are going in the outward direction. So here option C is the correct option, sigma by epsilon naught and is normal to the surface. Everyone copied this? Finish this? हो गया है सबका? Okay, I will end this session. So you can leave this meeting. Okay, so copy this and leave this meeting. For last question, option C is the correct option. Okay. Everyone can leave the meeting. So I'll stop today. Is everyone copied? Once you copied, then you can leave. Okay. I don't know, someone is sleeping, that's what they are remain there online.